Hi everyone, my name is Majid Sarvi and very pleased to be here. And thank you for the hospitality. I really appreciate it. It's been a fantastic first visit to South Korea. I was a big fan of football and watching your team all the time, enjoying the World Cup, what you did. But got a chance to come here and thank you very much for this opportunity and put some acknowledgement there for Professor Inhi Kim, Professor Kita Jang and Professor Guan Jang. Thank you very much for having me here. And as mentioned, I'm from the University of Melbourne, and my research area predominantly covers two areas. First one is this one, and the second one is crowd dynamics that I will talk about it. That's pretty much my hobby research, but this is my main activity. And I put some slides here. You may know some of it, but we could have interactive session. If you like to ask questions, interrupt me anytime. Happy to take questions. And let's see what can be done in this area. And I'd like to also acknowledge a lot of my colleagues and students and collaborators that contributed to this. So it's not all mine. So I take the credit, but a lot of people contributed to this work. I'll start with a bit of probably you all know why transport is important. Most of the country's transport is about 10% of the GDP. So it's quite a big large sector of the economy, and this is from World Economic Forum. They did a survey from 25 cities, and as you can see, transport is stayed on the top. It was quite amazing, even stayed higher than education and health as an average. So it's a very important thing for people. I put a bit of background about Australia, so basically, our population grow very fast because we get a lot of migrant coming to the country, and it's expected that the population by 2040 become 43 million. At the moment, we are standing around 24 million. So it's a huge growth. We also have lots of congestion. So Inhi knows about this. In Melbourne, we spend about 76 hours a year in congestion. And this is costing us about 18 billion. And if we do nothing, in less than 7 years, it's going to be 50 billion. So it's a huge amount of money. And 85% of Australian, they have, this kind of age profile. So it's a challenging aspect of transport system to provide mobility to this, demographic. We also have millennials that they grow up differently and they have different requirements. And also we have a lot of migration between cities. So for example, Melbourne now overtook Sydney in terms of become the biggest city in Australia. It just happened 2 weeks ago. So basically what happened, Sydney becomes so expensive, people started to come to Melbourne because they could basically purchase house and settle down, so population going up. In terms of freight and city logistic, again, we have a lot of challenge. We have about $220 billion in this sector, so it's a big chunk. And the task of freight is tripling by 2050. I think probably you have the same trend in Korea or maybe in other places because a lot of people do e-commerce. So my wife buys $1 things and somebody come with a truck or a small car and deliver it at home. So a lot of city logistic happens now, which didn't happen 10 years ago. We didn't have that luxury. So we're buying more stuff online. COVID contributed a lot to this behavior. And again, truck traffic is predicted to increase 50% by 2030, and again, going to cost even more if we do nothing about it. So a lot of challenge. What about infrastructure? I don't know about Korea, but in Australia, we have about $300 billion investment required. Current annual budget is about 29, so big shortfall. And in terms of quality of road network, freight network, etc., you can see 65% of road are in less than good condition. 25%, bridges need significant repair because it's a big continent. I think US is pretty much in the same sort of situation, and we also have an issue with rail. So overall, the transport system is graded at C. So A is very good, B is good, C is adequate, D is poor. So we're very close to go from one side to another side. So again, it's challenging. And I don't know about Korea. In Australia, we collect tax from fuel and put into the transport system. And electrification become a problem because electric vehicle doesn't pay. So government is looking to how to address that. But if you look at the 38 cents per liter to 40 cents in this many years, so that the income has not gone up significantly because you cannot tax more than that. Nobody accepts it socially. So this bucket becomes smaller, the cost goes up. So population, freight, infrastructure, and then you probably heard about a lot of this, a lot of promise in technology, connected vehicle, autonomous vehicle, drone, people using data. Australia, like probably Korea, you probably more than us, we're using heavily mobile phone, 90% of adults using a smartphone, one of the highest in the world. Real-time traveler, so a lot of things, and a lot of promises. And this promise has been around since I was a PhD student, but now become more real. But what is missing, you guys, what do you think is missing, if you look at all this big picture, anybody has some idea? You're a student, you need to answer question, you cannot just sit and enjoy the talk. So anybody want to give me some sort of, suggestion, what do you think is missing? I think what I pictured is pretty much the same everywhere, doesn't matter which country. What do you think is missing? And I can think about it. You're still shy. Okay, that's okay. If it was my class, when I was teaching, I'll give the student 3 marks. Tell them, give you 2 marks if you answer. And all of the time, people will start answering. But anyway, this is not lecture. So to me, what is missing is how to bring everything together. So a lot of these promises here, they're piecemeal. So they may be addressed part, but collectively, they cannot address the big issue we have. So have this in mind. I'll come back to this a bit later. So connecting automated vehicle. This is a real picture. So the concept is old. So I don't know, this is 1950 or something. The concept is old, but the technology is picking up, right? So let's have a look. You probably know what is connected vehicle, what is autonomous vehicle. Anybody doesn't know connected vehicle, autonomous vehicle, what is the definition? So anyway, you can read for yourself. So connected vehicle talk with each other. So vehicle exchange information, different type of information. So V to V is called vehicle to infrastructure, like here, infrastructure sends some information. And then we have autonomous vehicle that using lots of different technology to drive itself, right? So I have this in mind. And then we also have the impact of connected vehicle and autonomous vehicle, from demand side to operation side. So probably you heard about all of this, all right? Some of this impact might be sort of blown out of proportion. Some people come and say, "Oh, autonomous vehicle is going to solve everything." Some people come and say, "Going to have a disastrous impact." But probably, if we use it properly, it has a lot of potential. We did a research. When I say we, I mean in Australia, there was a very good research from probably one of the best in the world, done by Infrastructure Victoria, the impact of autonomous vehicle. Read it, it's very nice, it's available publicly. So they mention about how much benefit it can bring to the economy if it is used properly. And they did a lot of economic and transport modeling around it. And what it pictured was if you use it properly, is really good, very important. So it's not as scary, because some people talk about autonomous vehicle is like a beast, you're going to be destroying a lot of things. And this is a different level of automation. You probably know this, autonomous vehicle has 5 levels. So no automation to fully automation. As you can see in level 5, there's going to be no human involved at all. So no pedals, no wheels, nothing. And I think in his car probably is level 2 or 2.5. So it still has human interaction. So these are some definitions. You look at the internet, there's so many different type of definition, but I just put one up here. And I like this SAE, they are really good. So that's a very good definition they put forward. So human versus machine, benefits of technology, they react much quicker, doesn't get tired, distracted or get drunk. This is a big issue in Australia, I don't know about Korea. A lot of drunk drivers can see more than a human driver, for example, dead angle, may communicate with other vehicle and infrastructure, so it's important. What are the human good at? So instead of better in making judgment in complex environment, we have something in Melbourne. I think if you've been in Australia, we have something called hook turn. It's quite unique. It's a very complicated maneuver. So you want to turn left. If you talk about Korea, you go to the right and then wait and then you turn left. It's quite crazy. Check it on YouTube. There's so many videos about it. It's quite nice. So behavior of other road users, we are pretty good in reading that. For example, look at the bicycle, you just make an eye contact and you know that you're going to go first or he's going to go first. So we do that very well. Weather condition is still, we are very good in understanding, different weathers. Drivers, diverse road condition, we're pretty good in that. And, I mentioned about this, for example. So in many ways, human is better, superior at the moment with this technology today. So when I was a kid, I saw this. It was in a magazine I was looking at. And that was the vision of autonomous vehicle. Again, very old. But this is probably the reality of autonomous vehicle, so it's still a big difference. However, we're getting much, much better. This is just to make it funny, but of course, it's better than this. But it started from that. I think in here, you had a bit of work like this in Monash when you had a vehicle with so many gadgets. And then path to connected vehicle. So a lot of OEMs stand for car manufacturers, major car manufacturers. They put communication to vehicles in a voluntary basis. Also a lot of aftermarket fitment. And this happened, it started many years ago, 6, 7, 8 years ago. And then in terms of infrastructure, this is what is lacking. So vehicles is equipped, but there's no infrastructure supporting it properly. So for example, if this intersection cannot communicate with this car, a lot of the benefit cannot be realized, but this vehicle can communicate with this vehicle. However, for example, if they don't know what is the signal timing, a lot of the benefits cannot be realized. I'll talk about it a bit. So, and connected vehicle is a very, very important step toward highly autonomous vehicle. So we believe without connectivity, autonomous vehicle cannot really happen in a big time. So connectivity is so important. And then continuing issues of automated vehicle, we mentioned a bit here, role of connected vehicle, no advantage of autonomous vehicle for traffic efficiency, emission, and energy, if you do not coordinate them, right? If you have every man and his dog kind of condition, it's not going to work. So we need to have coordination. And there still is a big sort of, debate. Who's going to do that? Google going to put car out, car manufacturer going to put them out. They have no idea about traffic signal management. So who's going to be in charge? All of a sudden a God will happen, in all of this and going to help everybody. Nobody knows. So, however, we know that if you don't coordinate, none of this happens. All right, and the scary things may happen. Then availability of connected vehicle, if OEM start to put that seriously in. And all of other issues, cyber security is also very important. And continue with this path, see how we go. So again, this is Melbourne University philosophy. We don't know if this happened. We kind of believe these two, connected vehicle, autonomous vehicle, are going to merge. We're expecting 2025, hopefully, but I don't know, maybe not. But there are some sign of that. So if these two merge, hopefully we get more potential in that sense. So mobility as service, for example, smart cities and all of that, and then some of this technology, they can work together. And the path forward, there's some of the examples. You probably, if you work in this area, you probably know. It's not going to be straightforward. All of this car become autonomous. Probably you start from freight precinct, airports, shuttle servicing, campuses already. It's a lot of places doing that, ride sharing. So these are the places you can control the environment. So you simplify the environment, become easier for you to manage it. There are a lot of fleet managers that the operator that they're very keen to get their hand to autonomous vehicle because it reduces the cost and also they can do more. So the lesson from this is mostly going to happen in this area before become private. If ever become private, means you can buy one. I can get access to one. So mostly happen from this way down. And they need some building blocks in terms of how to do it, and how to take it forward. Safety is extremely important and is a big challenge everywhere, developing and developed countries. So how this technology can help to reduce the risk of crashes and people dying is very important. And basically, the future of transport, is infrastructure important? Car manufacturers that working on autonomous vehicle, they said, don't worry about anything, we fix everything, but it's not going to be like that because we need infrastructure. So it's going to be like this, it's going to be like this, or like this. So we need to find a balance. And also there's another challenge, I don't know if you follow this, there's a big debate and kind of like a competition, ugly competition between telecom companies that's supporting 5G and another type of communication is called DSRC or G5. Anybody knows what is DSRC? So it's standing for dedicated short-range communication. So it's a dedicated channel just for connected vehicles. So for example, if you're operating Wi-Fi, you cannot use that channel. So it's dedicated, so it's not getting interrupted, and therefore it's safe. So that's the meaning of it. However, there is a big, as I mentioned, competition. Telecom companies wants 5G because create business. And the problem is, DSRC has been studied for the past 10, 12 years. Significantly, it was ready to go, but didn't happen. And now 5G is there and it's still, pushing. The problem is people are still dying on road and this technology can help them. However, still we have this fight. Even in Australia, recently, again, government asked which technology is better, which is a wrong question, because both of them are good. So, it's like you have two different medicine and you can bring them to the market. Doesn't have to be one versus another one.
Do you have any answer for now? We are facing the same issues.
I think what we put to the government was use both. For example, DSRs is extremely good for safety, where fraction of a second is important, right? But 5G is good for network. So you can start using it now. The combination hybrid, is the best. And gradually, if 5G become much better and much more penetrated, you can use it. I don't know about Korea, for example, in Melbourne. In the middle of the city, you may have 5G very good. But the moment you go a little bit further, there are so many black holes. So if you rely, for example, on safety for 5G, it's going to be very, very challenging, right? So hybrid, that would probably be the best. Because there's no telecom company can guarantee 5G is going to be everywhere. It's so expensive, right? So, and another issue, I don't know about Korea, I haven't seen so many bicycles or pedestrian around, but maybe in Seoul you have much more. These are actual photos. So see how many bicycles we have, how many people walking. So it's very important. It's not just about cars, it's about everybody, it's about system. So connectivity can help all of these people, not just cars. I'll show you some examples. So our solution, we said the future of transport, everybody knows all this acronym, you know, and basically, you know, we need to focus on providing mobility, not using different technology. And we need a, you know, this is very key. We need a system approach, working technology, and hands-on experience, sorry for the typo, and good data. So this is very key. So we need all of this. Right. So let's see. So I try to picture what is happening, what is going on, what are the challenges, and you know, in order to address those challenges. So in Australia, we started a project in 2017 from concept. It's called AIMS. Standing for this is arguably the largest connected ecosystem in the world. So this is a big area in Melbourne. Melbourne University is right here. And this area is CBD or downtown. So this area is much larger than the Melbourne downtown. So it's over 100 kilometers of road network and has the, you know, the most complicated transport issue you can find anywhere in the city. So we have Melbourne Port, Melbourne Airport here, a lot of people living in the east suburbs, so a lot of trucks going through this area. This area, and he knows, is very vibrant. A lot of young people live, a lot of bicycles, a lot of pubs and bars and restaurants. So trucks moving up and down is the heaviest cycling corridor in Melbourne, going from this mid-rise area down to the city. We have about 1 million people walking to work in this area. We have trams, we have buses, so perfect place to study complex transport issues. So we fitted a lot of devices in this area. I'll show you some of them. And we collect more than, you know, from more than 10,000 devices every second. So we're collecting lots and lots of data, and you will see why. For example, collecting a speed, volume, vehicle type, traffic noise, environmental data, a lot of image, passenger counting, so on and so forth. So a lot of data. So we have over 52 companies collaborating and government. So you know some of them, Lexus, for example, you know, you may know Unix. Unix is basically Siemens, land transport. You know AWS, for example, or EasyMile. Toll is a large freight company. You know, Cubic is an American company. You know, Cisco, so on and so forth. So many companies. And I always say this slide is not to impress people, it's to show how difficult it is to work in transport ecosystem. It's truly multimodal. So you need technology company, you need you know, software company, you need government, you need transport operators, you need everybody together. So this is our, you know, Post, for example, you know, Scania. This is a Norway company building, you know, devices, you know, and so on and so forth. So the list goes on and on. So these are some of the devices to get some idea. So for example, this is a DSRC connectivity device, and this is connected to the signal management. So it's a very tight integration. So this is another device, is a LiDAR sitting on the top. This is environmental sensors, for example, here. We also have so many cameras. This is a bell-shaped camera. This is what you see. So every intersection in that area has a lot of device. And we also collect all the information from the loop detectors that exist on every intersection. So every lane has some detection. So all this data comes to us. And again, we couldn't do it without government participation, because government allows to, this is all infrastructure belong to government. We install our device and connect them to the traffic signal. So we can receive the information from from the signal. For example, we know when it's green, when it's red, when it's yellow.
Can you also send the information to the check light?
Yes, we have some project we push data back to the intersection. However, not at every intersection. And I'll talk about it. That's a very good question, actually. Actually, it's very simple technologically, but in terms of government policy was a bit of a challenge. So we also put a lot of devices to public transport. This is a connectivity device we put to public transport buses. This is the top of the bus. We drill down, put this device connected to the CAN system of the bus, so we can receive and send information. This is a truck. It belongs to the biggest supermarket chain in Australia, Woolies. I don't know how many stores they have, so we put devices there. This is the boxes in my office. They're full of devices, and this is the mock-up we built to put devices to trucks, for example. We also put devices to trams. This is a collaboration with Toshiba. They put a stereo camera in front of trams to collect some information. We're basically trying to calibrate the image processing. And when the tram moves, it collects a lot of data, and you can do a lot of things with this data. For example, you can estimate the length of the queue. You can understand the length of the queue, how many vehicles are waiting in the queue, which is very challenging to pick up, and is a very important factor to optimize transport system. All right, you need to know how many vehicles are waiting. And you can show it on a map. It also counts roughly how many passengers are waiting on both sides. So you know how many people waiting, you can manage your public transport much better. And also you can look at the safety. For example, the tram can get some notification that maybe apply emergency brake in case some people walking on a track. So it could have so many different applications in that sense. We also put devices in public transport. As you can see, we put a lot of Wi-Fi counter inside. This is a big public transport station, multi-level. It's called Melbourne Central. So we put these Wi-Fi counters, and the idea was to understand the people movement on a platform. So it's not just car. We did a lot of project with also public transport. This is another project. We call it Intelligent CAPS Corridor. CAPS is a very famous company based in Austria. They're very famous for DSRC and connectivity, CITS, toll collection. So the idea is to use the corridor inside AIMS to apply a lot of different technology, and we would like to operate this corridor in a very pragmatic way. For example, we want to predict safety and then manage the conflict before happening. For example, if we see the amount of conflict in this intersection going up, in the next 10-15 minutes, we could reduce number of, for example, trucks to the corridor, or we could deploy some more, speed limit, bring down the speed limit, those kind of things. So it's a flagship project to manage the corridor in a much more integrated way. And this is some of the footage of the camera. You can see, a lot of stuff in the intersection is fantastic for, safety study. We also have our own autonomous vehicle, which we operated in the campus for a student to see, and also we operated outside. And the idea was basically to understand the issue with autonomous vehicle. These are the old generation autonomous vehicle. We also put different devices to this vehicle sometimes to test, and so on and so forth. So we have kind of different stuff. This is very interesting slide. So this is the cabinet. Every intersection in Australia and probably another 170 cities around the world using the same system is called the SCAT. This intersection has this controller next to it, and this is the technology inside that cabinet. So the question is how to augment it, because you cannot get rid of it and put a new system in. So the idea is how to augment it. So in this project, we were putting cameras and other stuff into the intersection in order to understand the multimodal, management of the intersection. And the question is a smart versus dumb technology. When you put a dumb technology, you're going to be there. So what technology I need to put, what I have today, what will happen in 2 weeks or 2 years? So it's not an easy question. So that's why we put this project together as aims. The idea was getting hands-on experience, issues, what you can do, and before you go and commit to any technology or commit to any solution. For example, in this one, one of the sort of lesson was we want to push some information back to Signal, right? So the first thing we realized was there is no government policy to support it. So even if they want to do it, they couldn't do it. So we needed to work with the government to have a policy allow a third party push the data back. It was not technical; it was mostly policy. But without it, you can't touch the intersection. Or, for example, we realized some of this camera technology have certain limitation for certain use cases. So we learned a lot together with government and also the companies that bringing this technology. For example, there was a company putting edge computing into the intersection. So using edge computing, you can manage different devices. However, the size of the edge computing was so large, it wouldn't fit because most of this cabinet are full of old technology. So reducing the size, for example, could be important. So many practical lessons. And then we did a lot of testing here. I think I show you one video. It doesn't have sound, but anyway, I think maybe you need to I'll explain on the top of it. So this is a project we did a few years ago, and the idea was this is Melbourne University vehicle, real road, as you can see, is not a mock-up, it's real road. This is one of our team members trying to walk with a mobile phone, and the idea was the intersection can collect this information and basically provide some warning to the driver. So we did two days testing inside the city, inside the AIMS project, so everything was real. All the information was real, and then, for example, this is participation from Cisco. This is the edge computing that handle all the information around the intersection. So basically, we were trying to smart the intersection by using some new technology. So in this case, we were putting edge computing into the intersection. So all this calculation, all this information happening at the intersection, not inside the car. So, and then providing warning to the drivers that, for example, there's somebody walking on an intersection in red. For example, if somebody with mobile distracted walking on a red signal, it could be detected and can be sent some warning to the driver. So we did lot of testing like this in real world. If you are interested, I think I can show you the web page. You can see a lot of information on it. So we did, and we're still doing a lot of tests like this in Melbourne in real world. So this is the kind of a street you can see, and so on and so forth. All right, I'll go forward. So this is another project. I think this is again probably one of the earliest project in the world when providing green wave to bicycles. So it means if the bicycle come to the signal, it get a green light and go to the next intersection, get green light to the next intersection, and so on and so forth. So the bicycle doesn't stop, go straight. So the transport system is not designed for this. It's designed to get green light to cars, not bicycles. So we put these cameras at every intersection. We put 2, so they pick up the bicycle and they estimate the speed and then provide sending the information to the signal to provide bicycles green light and hand the information to the next intersection and next intersection. So this is quite a cool project to increase the bicycles, and safety of them in Melbourne.
Does it interrupt the car signals?
Yes. So, for example, if you're going down a corridor, usually the car gets green light, but now bicycles get green light. So the speed of bicycle is lower, and everything is different, right? So instead of cars, bicycles get green light. So it's quite interesting. And this is a photo. So see, this is a bicycle lane. And see how complicated this is the camera that picks up there is bicycle coming down and provide green light for the bicycle to go through. And next intersection and next intersection. And look at how complicated is this intersection. You know, this vehicle want to turn left can cut the bicycle. So again, connectivity can help a lot in this kind of conditions. So we put this camera here, connected it to this. This is the cabinet I showed you inside. So this controls the intersection in terms of green, red, everything. So this camera is connected to here and is totally integrated with the system.
So how many intersections in series?
At the moment we have 16, but again, the government wanted to learn from this project and then scale it up to many, many more intersections in Melbourne. So that's why, you know, a project like AIMS is so important, because you can test, understand. For example, one of the issues we figured out, there was a certain routers that control the camera, they drop out. And the government buying these routers without knowing that this is issue for this kind of technology. So they need to change it, for example. You know, so that's so many practical. Or the setup of the intersection in terms of how far from intersection I need to pick up the bicycle. So you need to learn and then adjust for other places. So many lessons you can learn from this kind of practical trial.
Is it like bike actuated green light?
Yes.
Or when the green light for the bike and then the next offset is optimized for bicycles?
The other way around. So you pick up the bicycles, you provide the green light, and then you make sure that in the next intersection with the speed that they go, they can get again green light.
What is the main reasons doing that? So that basically you keep the certain level of safety for the bicycle.
And also efficiency, because this corridor, a lot of people working, living in this area in the north, going to the city in the south in the morning. So this is like, you know, 10, 15, 20, 30 bicycles going together. So why they should stop when there are 4 cars going through?
The car drivers don't complain.
Nobody care because because government is interested to increase the active transport by 30%. So this is active transport. And also safety. Safety is so important, right? I get back to this. You know, as I mentioned, if this car turn left, can crush this bicycle. So it's very, very complicated environment. So we have right now a project that is going to start hopefully before end of this year. So one of the use cases we are going to do is going to broadcast the presence of bicycle or motorbike to the intersection. For example, you know, we have this camera here. We also have a DSRC. So camera pick up the bicycle, send the information to the roadside unit, and then there could be a variable message sign here announcing that there is bicycle or motorbike in the vicinity of intersection. So driver become more cautious, you know. So for
visual display.
yeah, variable message sign. No, it's showing, for example, this is a bicycle or this is a motorbike, and it also could go to the inside the vehicle. But if you have variable message sign, even vehicle without connectivity, they can benefit out of it. So it's trial. We don't know exactly what will happen, but we could collect some information before, some information after, and then look at the safety benefit of it. We're gonna put devices to garbage truck collection because they turn around a lot, so they can collect a lot of information. We can look at the conflict, near miss, and those kind of stuff, which is very important. So again, this technology helping, we call it vulnerable road users, bicycles, motorbike, and pedestrians. I think could have a lot of application also in Korea at the intersection, you know, or any other places. This is another project. We have this level crossing in Melbourne. A lot of train go through the road street, and there is a boom gate coming down. And so many of them, you cannot technically remove them all because it's going to cost and also interrupt the traffic. So one of the projects is to put these cameras up here, understand the length of the queue. If they're going back to the level crossing, we're going to increase the green light so the vehicle can go. So they don't block the intersection, because blocking the intersection is very dangerous. Look at this. So this is train going through, and if the intersection, you know, a queue come back all the way here, it's going to be very dangerous. So you can detect it, and then you can provide more green so the vehicle can go through. So those kind of stuff. This is another project we collaborated heavily with Lexus. So it's a typical connected vehicle testing in a real environment, looking at this kind of use cases, advanced red light warning, road hazard warning, for example. This could be done by 5G. In vehicle speed, conflict with tram. So for example, this vehicle turning left, colliding with the tram. So we wrote 3 white papers. Is available on the AIMS webpage. You can download, have a look. So amazing project. I think this project helped Lexus a lot in terms of understanding connectivity and how to use it in a very complex road environment. So it was not, as you can see, everything is a real world. Is not off the road or anything like that. So at the end, I just want to tell you, we have 5 disciplines within the transport technology. As you can see here, we have connected automated transport, public transport, travel demand, freight and city logistics, and also computational transport science. So I mentioned this, we're doing all of this, lot of data collection. And again, I'll ask you a question, what is missing? These are what is missing. You need to have good data, you need to have good understanding of transport system, and then you need to bring the system engineering together. So we're building lots of machine learning models using all this beautiful data that we're collecting in order to run the transport system. So that's the future. For example, you could use a generative AI in order to understand the conflict at intersection. You could use very cool machine learning at everyday progress to do much more versus the traditional way of doing transport system, which was using a static model. And those models, they reach their maturity, they reach their highest potential, they're not going to get better. They developed in 1970 in Detroit, right? So machine learning every day is better than yesterday. So this is what we believe, good data, good insight, good experience, combined with latest technology, are going to help us to solve some of the big issues in transport, such as safety, congestion, and emission. So without it, there is no way you could reduce congestion, reduce safety, conflict, and emission. So we're doing this project. It's called City Brain. So we're basically trying to use all this amazing data that we collect, which is quite unique. Probably there's no way around the world you can find this much data in one location. It's like a lab. You see so many things, and out of that you can create solution, and then you can take it to other places. And I think, again, Korea is a fantastic place for the same thing because you have so much high tech. Every intersection has a lot of technology. You can do the same. And we believe this is the only way you could address some of the important challenging issues. Because the challenges are old, same, right? However, now we have a chance to address majority of them using the right insight coming from right technology. Anyway, this is our webpage if you're interested. And this is the email. You can subscribe if you like. And on this webpage, you can find lots of video, lots of white papers, lots of news about what we do. And you can keep up, basically, up to date with what we do. And yes, please reach out if you need any information. Thank you very much.
Any questions?
Thank you very much for your
Pleasure.
This EMSON project is there a certain period of time it ends or it keeps going? So is it supported by government or industry partners?
It's a collaborative project supported by all those companies and government. So far has been around 40 million Australian dollar invested in this. So times it by 1,000 become won or something around that. And it's going to be continue for many more years. Because, interesting, when we started the concept, we started with a paper, which was a concept. And then we started talking to government and industry, and they came in one by one. And now it's become so important for many of them They actually so involved, they want to do more. Because if you are a tech company, this is perfect for you because you can develop technologies that you cannot do it on your own. For example, look at Cisco, for example, right? So Cisco has fantastic edge cloud computing. However, if you want to do it in transport, it's not like a factory. You can go to a factory, put a device. But road transport is so complicated. You need government partnership, you need academia, and then you need industry to do this kind of work together. So this project helped a lot of industry to understand the value of academia. And no matter how big you are, when it comes to transport, because it's so complicated and so, different, I don't know, tech people, they call it vertical. There's so many verticals that you need to combine, you need to connect. That doesn't matter how big you are, you cannot do it on your own. That's why companies that are trying to bring autonomous vehicle on their own, they're going to fail, all of them, because they need system.
So in practice, you're working with the industry partners, then these guys are all exposed on devices on the street, then they collect the data. That's okay. But what's the goal for the university? What is the university doing here?
We are, first of all, the data comes to Melbourne University.
First.
So we collect the data. Then we give it back to our partners. So we have all the data, so we can do all this research. The second thing is we are very neutral ground. For example, we have several technology doing same thing, and we write, for example, document about pros and cons of all of this. And also we learn a lot of working with this industry, things that we didn't know about it, right? So it's a truly collaborative work. So companies lead, sometimes government lead in terms of basically funding the project. And most of the time, probably 80% of the time, there are not just one company, many together. With the Lexus project, we had 9 companies and university collectively working together. So Melbourne University actually collecting all the data.
Any other questions?
Thank you, Majid, for a fantastic talk. I'm just wondering whether, because you develop so much beautiful technology here and work with the partner industry partners, and develop this Australian integrated multiple system. So I was wondering about whether you evaluate, assess this kind of whole system every year, and to see whether this whole system actually kind of prevent all the existing or the challenging problems in the cities area.
Yeah, absolutely. I mean, when we started, we didn't even know how far we can get because you don't know what you don't know, right? However, we very quickly realized the role of network system engineering, integration, connectivity, and the value of good data in terms of helping to understand how to solve the issues. For example, as I mentioned with the vulnerable road users, no car manufacturing can do what system engineering can do because you have technology that goes to the car, but you don't control the intersection, right? So you are limited. You need this contribution from everybody else. And government role is to supporting infrastructure, and they need to know what infrastructure they need to support, and also how to enhance the infrastructure gradually. And on the top of that, as I mentioned, machine learning is an enormous opportunity here. Because if you have good data, you can solve some of the issue we were struggling for many years. For example, we could very dynamically understand congestion, predict them, and also find solution for them on a real time, and being able to help government. The signal management, I think in here, everywhere, Australia, they are suboptimal, right? So theoretically speaking, if you want to optimize signal management, basically you cannot do it with the current technology. And also, you don't have a good understanding of every players. Whatever you do is somehow suboptimal, right? For example, I might optimize throughput for certain mode, but others may not be optimized, right? And then you add on the top of that a space management. So you can manage the time, you can also manage the space. For example, you have 4 lanes of traffic, you can manage it in the morning, 3 lanes going to the city, in the afternoon 3 lanes come out. And we are not really doing that very effectively. Most of the effort has been always on the time, not the space. So combining the two with the good data, with every player, you have a very good chance to being able to get close to the optimum, management of a signal or the space, which is the holy grail. Because if you can do that, you can reduce, congestion. You can improve the safety, which is just the sort of what everybody wants to do.
Any other questions? Actually, I have 2.
Sure.
Okay. One is administration question, and second is the technical question. There are many participations from the companies.
Yep. How
they fund you?
Very interesting question. I mean, I didn't get through all of this. Where we started from a good sort of, good kind of faith, good willing to do work together. But we gradually started to have some framework of collaboration together. So AIMS is an entity, has a very sort of good governance around it. So companies fund the university for many of these projects, or collectively funding a project. Also the government fund projects. For example, in one of the projects, the leader could be industry or several industry, or could be government. For example, government was interested to understand image processing technology, because there's so many companies provide that, right? So they come to AIMS, because they are partner, asking us to look at several of this technology and provide them with the feedback. So as university, we engage industries, we do the project, we provide the sort of, the answer back to the government. And the other thing is our program manager is seconded from government. So our program manager actually is a government person. So he gets really good understanding of what's happening. So it's very, very close collaboration with government, industry, and university. So it's not like, they come and give us the money and go away. So we do it together.
So to add on that question, when you started with this one, in the beginning, how many companies did you join?
The beginning, I think we convinced 1 or 2, and then we quickly go up.
1 or 2?
Yeah. This starting was 1 or 2, but the government was very important. Government was very, very supportive. And then very quickly, people understand the value of have a system like that. For example, doesn't matter how rich you are or how much money your company has. If government doesn't allow you to put your device on the pole, you can't do it, right? So that's one of the benefits. I don't want to tell the name, but we had this global CEO of a major company come down to Australia, and then this is a real story. And he spent about, 1 hour in AIMS, and we're telling him why he needs to invest more. And then we opened up one of this intersection cabinet, and we showed him the device and said, your device is here. How many of this, for example, in your home country you can put into intersection? And he literally said maybe 2 or 3, and said we have here, 8 intersection. So, that's the thing. You have the collaboration and commitment from government to help, which is very important, because the infrastructure belongs to them, and they allow this to happen. So not many places around the world you can put this stuff to the pole, because that's not very easy.
My second technical question is, you have many projects going on.
Yep.
So they generate their own data set. But your communication infrastructure is fixed. How you define the message set from each project?
I mean, some of the data is collected continuously. For example, like a speed volume, count, some of the emission data, some of the image data that keep coming. And we have different channel of collecting them. But some of them, for example, like a Lexus project, is dedicated sort of communication. So we get the companies to help to collect it and then they pass it to us. But most of the time, when we have a, for example, concurrent project, we need to establish, how this data is getting collected. But overall, at every intersection, we have the possibility of collecting data using either 4G or also some fixed government sort of, cabling that they have at intersection. So this way we kind of can collect most of this data without an issue. However, for connected vehicle, if we have a lot of connected vehicle at intersections, which is our next project is having every intersection in Ames, truly connected with intersection with the signal management. So every intersection can broadcast the signal. So for that, we need to definitely design a very good data collection at the top level. However, looking at many companies working with us, that is not a difficult challenge. But practically, not many places around the world you have, for example, 1,000 connected vehicles working together. So people understand the challenges, because mostly we're limited. So I don't know about Korea, for example, in the US, in Michigan, they had few hundred. So there was not any cases that you have 1,000 cars connected come to one intersection, in a short amount of time. So you can understand, is there going to be dropout? Is going to be any issue? And that's the next level of sort of, direction that many places they like to do.
Another.
I want to add some question on this questions because let me introduce myself. I'm Tego and I'm in this security.
Yep.
And I wonder when you send all the data set from the infrastructure to vehicles or devices or some other devices, have you estimated, evaluate the delay time, or if there is a lot of delay, what kind of method you did to improve to mitigate the delay?
Yeah, it's a very good question. I think come back to earlier question about the latency. 5G, I mentioned 5G DSRC. So when it comes to latency, DSRC has been totally tested, which has pretty much close to zero latency, which is very good for safety. For example, if you have two vehicles coming to the intersection, one of them going to cross on red, so you need very quick detection and very quick sending message, for example, to one of the driver to slow down, right? So that's one of the classic use cases, I think, in here. So advanced red light warning, right? So for that, DSRC works very good. But when it comes to 5G, that's again one of the gray area. Nobody tested a lot of vehicles with 5G coming at one intersection to understand if there's going to be a dropout or any latency issue. Theoretically should be not, but practical sort of setting is very different. So again, for those kind of scenario, a lot of people believe hybrid system is good when you can do the safety critic application using dedicated short-range communication, and those that are not close to real time left to 5G. For example, when you go outside the urban environment, for example, you could have a roadwork net message. So you don't need the DSRC, it could be 5G, So another sort of testing that happened within the Ames, we use the edge computing. So when you put a device into the intersection and that device communicate. However, still, we don't have 100% answer that one technology is better than the other one. But there are lots and lots of evidence and lots of tests around the world that people done with DSRC, which is pretty much guaranteed that could improve safety. I think one of the major one was in Michigan, come out of the MCT study. They wrote a report. I think also in Japan, because Lexus, Toyota, I forgot the number, but I think they have a few 100,000 connected vehicle. They showed the benefit of safety using those stats. So there are solid evidence that this kind of technology can help and improving the safety and efficiency.
Right? Well, last question. Okay.
Connected.
Optimize the traffic condition.
Yep.
Release this kind of
Yep. Again, very good question. I think there are a lot of study we have done also as well. If you're interested in some papers, you can have a look. So we look at that question. What is the penetration you get benefit in terms of efficiency, in terms of safety? So the ranges start from 10% to 20%. When you have 10% connected vehicle, they can really improve the efficiency of transport system. So we have at the moment one study started in January. We call it connected data. So the study is about, and all the road agency, probably 1, 2, 3, 4 road agencies in Australia are involved. So it's a lot of cities together. Brisbane, Melbourne, Sydney, and Perth. So 4 out of 5 largest cities involved. So the idea is to look at the GPS data from highest quality, which is connected vehicle, to lowest quality, which is just GPS data, and understand the value of that type of data for transport management. It's not for safety or whatever, it's just for transport management, how you could use that kind of data for network transport management. So at the moment, the good news is that a lot of companies that they have access or have business around the GPS data, the telecom companies, fleet companies, and all the new vehicles, they have SIM cards. So they have some level of data, but some of them is poor. For example, the GPS might have 20, 30 meters accuracy, but connected vehicle could be up to a few centimeters. So very high quality to very low quality. So the study is about, if you have that kind of high quality data, what are the use cases for transport management? If you have this low quality, what are the use cases? So again, we think more than 10%, you have a jackpot. You can definitely do a lot. For example, you can coordinate transport system. You can give priority. You can start to understand build-up of congestion mid-block, because mid-block usually we don't have detection system. Everything is at the intersection mostly, right? So there are lots and lots of use cases. Or you can predict the safety at intersection, because they go through the intersection. You can look at it, and then you can bring that to the to your solution. So I hope I could answer your question, but yeah, probably about 10% plus.
Give us some more time. 1 minute.
Yeah, sure.
Yeah, 1 minute.
Ask him.
No, I'm happy to answer questions. I have no problem. I came from Melbourne for this, so get me working. No problem.
As you can see, I'm a student. Some student probably came on joining the University of Melbourne.
Yep.
Your team. Do you remember how many PhD students you got?
I think our team is quite large. I think I'm talking about my own research, but AIMS is very, very large. So many people are involved. But my own group, I think we have probably now about maybe 30 postdocs and PhD student and research assistant, maybe even more. So we have lots of PhD students.
Okay, what is the qualification for our student to join your team?
Oh, okay. I think Melbourne University is very good university, as you probably know. So if you hit the Melbourne University requirements, then for me, what is important, I like people who are hardworking. So very important. And also people that think outside the box. And also not afraid of doing new things, right? Because this is so interesting area. And I think everybody getting involved in this is very good, very interesting. And also we have very vibrant group because you see a lot of real-time, real-world stuff. So it's not just sitting behind your desk. You can go get involved. You can work with companies. And companies are great because, you know, they provide lots of insight. So when I did my PhD, I remember I put cameras on my shoulder, walking, you know, going up these buildings, put them out there, you know, looking at the traffic. So it was very different. But now we can collect really good data from traffic. So I think transport is a fantastic area. You know, it's very, very sexy area now because all the high tech are in transport. It's important. I showed you, 10% of GDP, right? So it's an amazing area, and it's a lot of cross-disciplinary machine learning, computer science, electrical engineering, transport science, traffic science. So it's really, really rewarding. And also you do something good because if you save life of people, if you reduce congestion, and everybody knows about transport because everybody wake up in the morning, they need to get out and basically be part of the transport system. So it's truly a very rewarding area, and I'm more than happy to have you guys, please. Yeah, reach out, and hopefully we see some of you working on many, many projects. So we always want more students.
Take a key test student.
More than happy. Yeah, more than happy. Please reach out. We would love to have some really good student, and I think again there are a lot of similarity between our group. So what you do is very similar based on what I heard from you and also Inhi. So it's a lot of common science. Yes.
Melbourne Uni and KAIST.
Yes.
Change it.
Absolutely.
Because that kind of thing is really.
Yeah, and also we're very happy to share data if you're interested. Some of the data that belongs to us, we're happy to share. We're happy to share our experience. We are very open to collaboration. We collaborate with a lot of groups, and I think we'd love to work with Korea as well, more and more. So please reach out and look at our website. There's a lot of information there. So please reach out.
Okay. Thank you very much.
Pleasure.
Thank him.
Thank you.